Good morning, students. Myself, Janesh Shah, Assistant Professor at LG Institute of Engineering and Technology. In our previous lecture, studied about that how can we insert data inside the linked list insertion at first, insertion at last, and this last topic was linked list insertion in ordered linked list. We have seen that what do you mean by okay, and how can we get a node from the availability stack? How can we insert at first, last, and in the middle of the linked list? Okay, so in today's lecture, we'll talk about the linked list deletion, singly linked list deletion. So let's start. Students, the first step is we talk about the singly linked list deletion, and then we'll consider circular linked list insertion. So first one is singly linked list deletion. So here deletion is a procedure. Okay, usually you have seen that in our previous lectures like in stack and queue, if you want to delete something, that's function, not a procedure, right? And during insertion, it's procedure, not function. But here it's totally reverse. Okay, why in deletion that it's a procedure, not function? Because in single linked list deletion we are not going to return anything. Okay, that's why it's a procedure. Okay, so here students we have two things. The first one is the x and second one is the first. Usually we know that x is a value, but here x is the address of the node which we want to delete. Suppose in our whole linked list, if we want to delete this particular node and address of that node is 1040, okay, so the x is becomes 1040. We want to delete a node which contains the address 2202, so the x becomes 2202 comma first. So here x is nothing but the address of the element which we want to delete, and first is a pointer which points to the first node of the list. So let's begin. First tell me that if I want to delete something from any data structure, which condition is be usually used? Underflow condition. Underflow of that particular data structure. Fine. So first we need to check the whether the linked list is exist or not. Okay. So how can we check that whether the linked list is exist? Okay. If linked list exists, students, then tell me first pointer pointing to which node? If linked list is there, then first pointer pointing to which node? First node of the list, right? Correct. But if linked list does not exist, there is no linked list is there, then first pointer pointing to nothing. That means null. That means if the first we check that whether the linked list is empty or not, and the condition for that is if the first is equal to null. If the first is equal to null, see, this is my first pointer, it pointing to null, that means underflow. Linked list does not exist. Then write underflow and just do return. Make sure return is just a statement. We are not returning anything. That's why it's a procedure, not function. Okay. So let's go ahead. See here the first is pointing to null. So it's underflow. Okay. Now the second thing we need to go is initialize search for X. Suppose students the linked list exists like this. Here is 10, 40, 50, 60 and 80. Okay. This is a singly linked list. Make sure this is a singly linked list. That means the pointer of the last node pointing to none. Okay. So here this is first and this is X. See, X is a pointer which stores the address of the element which we want to delete. Okay. So if anyone asks to you that which element do you want to delete, 10, 40, 50, 60, wait. I'm not talking about the values, but we want to delete a node with address, and the address of that node is X. Okay. So here I want to delete X or a node which has address x. So x is a pointer which pointing over here. So students, I want to delete this node. Okay, but the value of that node is 60. Okay, but I'm not gonna say that I want to delete 60, but I want to say I want to delete a node which contains address x. That means x is a pointer which pointing to the deleted node, a node which is going to be deleted. Fine. So first, what we need to do, if we want to delete x, that means we want to find x first. Okay, if I don't know that where is x, how can I delete it? So first I need to initialize search for x, and so that in the previous examples we are used to take a pointer save. If you remember that we are usually take a save pointer as a temporary pointer. But today I am taking another pointer which is known as temp, because I want to traverse in my linked list. This is my linked list. I want to move forward from the first node to another, then another, then another, then another. So for do the traversal operation, what I need? I need a temporary pointer, and today I'm taking temp as my temporary pointer. So here is the syntax is temp arrow first. What I need to do? I need to just first point temp to the first position. So see, here is the temporary pointer which is pointing to the first node of the list. Okay, fine. So I'm just initialized it, and then what I need to do? I just need to my temp pointer forward and forward and forward until and unless I get X. Got it? Okay. So students, let's move forward. The next slide. So now the next step is find x. See, I want to find x. I want to find x. Okay. To finding x, I have already initialized my temporary pointer. Okay. But so wait for a minute. Let me just minimize this screen so you can watch it. Okay. See, I think this is now visible. So repeat through step 5. Students, 3 steps are continuously moving in the loop. Okay, continuously executed in the loop. The first step is this, step number 3. Repeat through step 5 while temp is not equal to x. You need to search inside the whole linked list until and unless you will get temp is not equal to x. Okay, this is temp, this is x. Both becomes at the same position. Okay. And another condition is link of temp is not equal to null. This is very usually we use in our previous examples, like link of save is not equal to null. Link of save is not equal to null. Save is also a temporary pointer, and temp is also a temporary pointer which is used for the traversing the singly linked list. Got it? So here 2 conditions are there. The first one is temp is not equal to x, and second one is link of temp is not equal to null. Make sure, because if link of temp is equal to null, that means you have searched the whole linked list, still you didn't find x. Okay. So after this, see, I'm just initializing my temp over the first. Okay. Sir, there is no x over here. Just wait for a minute. I know I did not show x over here. Why? You will understand in few minutes. Okay. So see, first I'm taking another pointer, predecessor pointer or predecessor marker. So first what I need to do, temp pointer need to initialize over the first, and then I need to initialize pred over temp. Sir, what is pred? Students, pred is a predecessor marker, a predecessor pointer. Okay. So see, predecessor marker or pointer which point to the previous position of temp. Okay. First we need to initialize pred and then move temp. Initialize pred, then move temp. Again. Initialize pred, then move temp forward. Initialize pred, then move temp forward. Such like this, we will work it out. So see, first we need to do initialize pred here. Pred is right now pointing to the temp. Okay. First what we need to do, initialize temp at first, then pred at temp. Now step number 5, move to the next node. Move to the next node. We have already seen if we want to move our save pointer to the next node, what is that save step? Save arrow link of save. Save arrow link of save. Okay. Same like that. If this is my temp, see, if this is my temp, then this becomes link of temp. This becomes link of temp. So what I need to do? I need to move my temp to link of temp. Temp to link of temp. Fine. Temp to link of temp. Fine. So here the step becomes temp arrow link of temp. So this is step number 5. See the animation. Step number 5. Okay, now again check the conditions. Step number 3, what is the condition? Temp is not equal to x. See here, temp is equal to x. No. Okay, link of temp is equal to null. No. Again no. So both conditions are satisfied. Then move forward to the step number 4. What we need to do? Pred will point to the temp. So here pred is pointing to temp. The next step is temp will pointing to the link of temp. See, 2 iterations are completed. Again, you will go with the step number 3. Check temp is not equal to x. See, temp is not equal to x. Link of temp is not equal to null. Both conditions are true. So go forward. Pred will point into temp, and temp will point into link of temp. Fine. Again, we will check the conditions. Temp is not equal to x. Yes. Link of temp is not equal to null. Yes, both conditions are true. So go move forward. So pred becomes at temp, and temp pointed to link of temp. Now wait, see the condition. Temp is not equal to x. Is that so? Yes, it's true. Link of temp is not equal to null. Check the condition, students. Link of temp is not equal to null. See the link of temp. Is it null? Yes. So this condition becomes false. This condition becomes false. So here your iteration will not go forward and you stop from here. Okay. That means, have you find temp? At the end of the list, have you find x? No. It means temp is not equal to x. Did you find it? No. That means x is not there. X is not there. So after the whole iteration, if you reach to the end of the list, see, you reach towards the end of the list and still you didn't find x. That means x is not there. So write node not found. Okay, so the condition for that is if temp is not equal to x, then write node not found, written. Okay, so now move forward. The next is deletion in single linked list. Again, so here, suppose just assume this is my linked list and x which I want to find it is situated at the first position. So just assume that x is at first. X is at first. If I want to delete the first node of the list, that means temp initialize that over here. Okay, temp at first. Now go to the next step. Check step number 3. If temp is not equal to x and link of temp is not equal to null. So temp is not equal to x, that condition will be false. So pred is not initialized. We will not execute step number 4, not execute step number 5. Just go to the step number 6. That is, step number 7, and that is delete x. See, here x is equal to first. Students, when x becomes first, when x is the first. Okay, so here x is the first node. So your temp will be pointing to over here. X is also here. First is also here. If I want to delete this node, what I need to do? I just need to move first pointer to the next node. So if this is first, see, if this node is known as first, then according to the rule of assignment name, this node becomes link of list. Okay, If this node is 10, 10 is the first node, then 20, 40 becomes link of first. Some of you students may ask that, sir, 40 can also known as link of x. Yes, you are right. It's also known as link of temp. Yes, you are right. Then why are we using link of first only? Students, you can write link of x, link of temp, link of first, anything, because right now temp, x and first, all three pointers are pointing to 10 only. Okay, so for 40, name of 40 can be link of x, temp and first. But usually I just go through the book, and for the normal writing, I just move my first pointer to the link of first. See the animation, the first it continues at link of first. See again, first will move forward to the link of first. Fine. Okay. So see, this node is now free from the linked list. How? So how can you say that this node is free from the linked list? Students, remember, linked list, length of the linked list is always known from single linked list, known from first pointer to the last node. Okay. So you have the first pointer pointing to 40, last node is 50. So length of the single linked list is this only. Now this node is free. This node is free from the single linked list. So what we need to do with this node, we will see it later. But take the another scenario. If x is there in the middle of the linked list, if x is there in the middle of the linked list, then what happens? What happens? Okay. So see, I'm just going to initialize temp over here. See, this is our first scenario, okay, that we have seen during the step number 2. Okay, so see, first we need to initialize temp over first. Yes, then we need to take pred. See, step number 3, pred. Okay, then you need to move temp to the link of temp. Again, condition satisfied, move pred to temp, temp to the link of temp. Again, condition satisfied, pred to temp, and temp to the link of temp. Okay, now go to the step number 3. What is the condition? Repeat through step 5. Check your notes. Check your notes. Repeat through step 5 while temp is not equal to x. While temp is not equal to x. Okay, so while temp is not equal to x, this condition is right now false. False. So stop over there. Stop over there because you have found x. Okay, we have already found x. So what we need to do? We need to remove this node, this 60 node. Okay, on which temp and x both are pointing. Okay. So one question coming in your mind is, why we take pred? You still didn't answer. Okay. So here is the answer. You just check it out. What we need to do, suppose students, if I want to remove this node, so after removing this node, okay, after removing this node, which two nodes are connecting each other? See, if this is 80, this is for 50, this is 60, this is 80, 50, 60 and 80. Okay, if I want to remove 60, okay, so I just left two nodes, okay, 50 and 80. So what I need to do, I need to combine both nodes. Okay, so same like that, I need to link of 50 to link to 80, link of 50 to 80. In linked list, in each and every operation, if you want to perform operation on linked list node, you need name. Remember that thing. Okay, you need name. You have to assign name to that nodes. Okay, students, temp pointing over here, x pointing over here. What I need, I just need this node. The name of this node is, this is temp. Name of this node is link of temp. So this is x. Name of this node is link of x. But what is the name of this node? You have no. If we are not taking pred, then we are not able to assign name to this node. So as I want to connect link of this 50 node to 80, I have to assign it name. That's why I got two pointers. Okay, I took two different pointers. One is temp, which is pointing to x, and pred, which pointing to the previous position of that node x. Fine. Okay, so now if I want to assign link of this node, so students, if this is 50, this is 50, sorry, this is pred. If this is pred, then link of this node is pred. Okay, link of pred. So what I need to do, assign link of pred to this 80. Okay, so what is the name of this node? Pred. Okay, what I need to cut this link of which node? Pred node. That becomes link of pred 280. What is the name of 80? What is the name of 80? See, the previous node is 60. Name of 60 is 10. So name of 60 is x. You can x or 10, anything, whatever you want. So name of 80 becomes link of 10 or link of x. So here we gonna assign. See, this is link of pred. This is link of x. So what we need to do, assign this link over here. So I'm just gonna write link of pred to link of x. See the animation, link of pred to link of x. Okay, so it goes like this. Okay, see, link of pred to link of x. Link of pred to link of x. Okay, so this link of pred now pointing to link of x. So now this node is not in the list, so it is automatically removed from the list. So this becomes our new linked list. Fine. Again showing it. See, this is link of pred, this is link of x. I want to remove this. So what I need to connect? I need to connect this link over here. Name of this link is link of pred, and name of this 80 node is link of x. So I just want to connect it like this, and this node is removed from the list. Got it? Fine. Okay. So I want to show you something else. Okay. See now, I have that deleted node. Deleted node from the two different scenarios. The first scenario is this deleted node from here. Another scenario is this deleted node from here. So after the students, tell me, if we want to insert something in the singly linked list, what we are doing? We are just taking the node from the availability stack, right or wrong? Yes. So linked list is like a dynamic memory allocation. If you have completed your work, okay, you just need to assign that node again to that availability stack. See, this is my availability stack. What we need to do, if we want to insert something, I'm just taking node from the availability stack, but here I am deleting the node. I have deleted the node. So after deleting that node, see, this is my node, deleted node. Suppose this is my deleted node. I need to assign it again on availability stack. Okay. So students, this is availability stack. In stack, the insertion operation as always goes on the top of the stack. Same like that, after deleting that node, I just need to assign that deleted node again to the availability stack. If you want to insert something in single linked list, I'm just taking node from the availability stack. Now after deleting it, what I need to do, restore that node to the again into availability stack. So return node to the availability area. Okay, so now you tell me what is the sentences or how the algorithm works over here. Okay, so see, I'm just put it down over availability stack. Okay, this is x or temp, both, whatever you want to say, because both pointer right now pointing to over here. So this is x, I'm just considering x. Okay, so this is x, so this is the link of x. Link of x need to point to this node. Link of x need to point this node. What is the name of this node? Avail. So first step is link of x to avail. Link of x to avail, and that is link of x to avail. Link of X to avail. Fine. The next is avail to the upside of the X. Okay. So what I need to do after doing this, I need to move avail to X. Avail to X. Because always top pointer pointing to the topmost element of the stack. So right now X becomes topmost node of the availability stack. Right. So need to move avail to X. Avail to X. So after this, avail pointing to X. Got it? Clear? So such like this, we are doing the deletion operation in single linked list. Fine. So now next we'll talk about the circular linked list. See. Okay, the last step is written. Sorry, I just forgot. So next is circular linked list. Okay. Students, just consider this is the single linked list. Fine. What do you mean by circular linked list? See, I'm not going to teach you each and every algorithm for circular linked list, because in circular linked list there is just a little bit difference in circular linked list from the single linked list. Okay, and the difference is that in circular linked list, the pointer of the last node pointing to the first node of the list. Okay, this pointer in single linked list, pointer of the last node pointing to null. Okay, so right now this is a single linked list, but after that, see, this becomes circular. Okay, because the pointer of the last node pointing to the first. Okay, this is just a little bit difference from single linked list and circular linked list. So we have seen 3 algorithms for insertion and 1 algorithm for deletion in single linked list. In each and every algorithm, you just need to change the last condition, which focused on link of save pointing to null. Okay, like see, for each and every algorithm, we have seen that one condition is different, like link of save is not equal to null. No, in circular linked list, link of save it is not null, but it's first. So what we need to change? Just write link of save is not equal to first. Got it? Because the last node pointing to null in single linked list, but in circular linked list, the last node pointing to the first node of the list. Okay. So most probably we just need to change the condition only. Okay. So I'm just giving you some little bit example, like I'm just taking one algorithm insertion and in circular linked list. So all steps are common, same as single linked list. Just first we need to check avail is equal to null. Then we need to obtain new to avail. Then again avail to link of avail. Then add info to X. Fine. See, I'm not gonna set the link over here. Fine. So here, first we need to check whether the linked list empty or not. If linked list is empty, then first is equal to null, return new. Initialize search for the last node. First save pointing to the first node, and then see, this is my node which I want to insert, and this is my circular linked list. Okay, so what I need to do, I just need to insert this node at the last. Okay, so first I need to reach to the last node of the list. That's why I'm just initialize save to the first. Okay, fine, and then repeat step. See, this is the change in condition. In our single linked list insertion example, we have while link of save is not equal to null, but here we have link of save is not equal to first. Link of save is not equal to first. Okay, what we need to do? Save pointing to the link of save. Save pointing to the link of save until and unless, and the traversing will work it out. Okay, save pointing to link of save. Save pointing to link of save. Right, and then after reaching to the end of the node, what we need to do, I just need to assign the link of save. If this is save, this is a link of save. This is save, this is a link of save. Assign link of save to new. Assign link of save to new. See, I'm just assigning link of save to new. And then link of new. See, this link of new to first. Link of new to first, because new becomes our last node. Okay, so link of new to first. I'm just moving right link of new to first. See, this is a change. Link of new to first. Okay, rest of algorithm is becomes as it is. Okay, so this such type of little bit changes you need to do in your algorithms of singly linked list. Okay, I hope you can do it by yourself very well. I'm just showing you last example, insertion and order in circular linked list. Changes in conditions only. Step number 5, the condition will change. It becomes link of new arrow first, and then in step number 8, the condition will change like this. Repeat while link of save is not equal to first. In that algorithm, we have written link of for save is not equal to null, but here you need to write link of save is not equal to first. Okay, that condition will change only. So such type of little bit changes are there in circular linked list. Okay, you just need to imagine or write or draw a figure of circular linked list in your notebook and write the algorithms for all 4 algorithms. Insertion at first in circular linked list, insertion at last, and I have already told you how to do it. Insertion in order. What are the changes are there? I have already taught you in this lecture. Then deletion in circular linked list. I hope you can do it very well. Okay, so just exercise circular linked list algorithms. It is same as a single linked list, but there are little bit changes because in circular linked list the pointer of the last node is pointed to the first node of the list. Students, in our next lecture we'll talk about doubly linked list. Till that, if you have any doubt, then please feel free to ask me, and keep smiling. Thank you so much.